Hello and welcome to this talk about progressive delivery in Kubernetes. My name is Carlos Sanchez.
And I'm Viktor Farcic.
So I am a cloud engineer at Adobe. I wrote some open source, a lot of it, like the Jenkins Kubernetes plugin, and I've been a long time open source contributor at Apache Maven, Eclipse Foundation, Puppet, and other things. And Viktor
works in CloudBees and as a product manager, and then he published some books and courses, and he's a Google developer expert. All the good stuff. A lot of open source, a lot of public work.
And we're here today to talk to you about progressive delivery. When have you heard the first time about progressive delivery, Viktor?
I heard it the first time from you.
Well, I heard the first time from Lunch Darkly. They wrote this blog about the history of progressive delivery. So that was the first time. And then James Governor from Red Monk Chips in Twitter, he was pushing it, and I said, well, I love this term. It defines very clearly what we're trying to do. So let's steal it, right?
Exactly. We're not going to invent anything new, right?
Right. So what is progressive delivery? It's just a new term to coin a bunch of different things that have been around for a while. So it groups together all these deployment strategies that try to avoid all or nothing deployments, where you deploy something, and if it's broken, it breaks all your customers. So we are trying to avoid that, and that's all these techniques fall into the progressive delivery buzzword, I say. So when you deploy a new version, you are not replacing existing versions, but you just deploy things that are running in parallel with the previous versions that you have deployed. And then you can decide whether you want to send live traffic. This is important. This is all in production happening. So you can send live traffic to the old version or to the new version based on whatever parameters you decide. And then you evaluate whether this new version is behaving correctly. And if it's so, then you can send more traffic to the new version. But if for whatever reason the new version doesn't behave as you expected, then you can start rolling back to the old version. And this is very immediate or fast. And just a percentage of your users could get affected.
So the main advantage really of continuous progressive delivery or running in parallel, it is really about avoiding downtime. Because if you do not run two releases in parallel, it is physically impossible to be able to deploy a new release without downtime. So running in parallel is a prerequisite for any attempt to do no downtime or zero downtime deployments. And then on top of that, we have all the benefits that Carlos just mentioned, that we can decide how much traffic goes to one release, how much to another, and increase the reliability and confidence we have in rolling out something.
So it's all about avoiding downtime and limiting the blast radius. So if something goes wrong, just some people notice what the issue, and also allows you to have a faster idea to production type of workflows where you are more confident that things are not gonna cause a big issue in production. So there's a number of techniques that you may have heard of. This is nothing new. So we have things like rolling updates. So this is something that you could have done with virtual machines. You can do it very easily in Kubernetes with containers, with pods. And basically it's just you have 10 pods running, and then you upgrade one to a new version. And instead of upgrading all the 10 at once, you upgrade one, check that that one is successful, or you have some maybe metrics. Then you upgrade 2, 3, 4, 5, and so on until you upgrade all of them. So you don't have a lot of control, but at least you're not affecting all the users at the same time.
So rolling updates is not that much about control. It's more about avoiding downtime. By replacing one replica at a time, there is always a replica running, be it of the old or the new release or both. So it's not that much about having control. You don't really control who gets to see what, and you cannot even control much whether you roll back or roll forward. It's more about reducing downtime than anything else.
Yep. And as I said, this is very easy to do in Kubernetes. Then we have...
It's a default deployment mechanism in Kubernetes. In other words, if you use Kubernetes deployment or stateful set, you're getting rolling updates no matter what you do, unless you explicitly change the deployment strategy to something else.
And then we have BlueGreen Deployment. This is something that I think it came from Martin Fowler. I mean, he was the first one kind of going through the definition, where you have two different sets of clusters or machines. One set with the old version, one set with the new version. And then you have some router load balancer in front. And when you want to deploy to the new version, you just flip the switch on the load balancer and say, all the traffic goes to the new version.
The main issue with BlueGreen deployments is that it somehow assumes that the best way to roll back or to roll forward is by having everything duplicated. It assumes in a way, and simply because it was created a long time ago, it assumes that rolling back, for example, would require creating of new virtual machines, would require a lot of many different steps. So in order to avoid the downtime, no matter whether we're going forward or backwards, everything needs to run in parallel. But now, assuming that we are using Kubernetes for most of our workloads, then the difficulty of going forward or going back is basically non-existent. So the whole idea about running everything twice in parallel forever and ever is kind of waste that could be probably avoided. So it is much better suited in environments where deployment takes time and scheduling takes time and what's or not.
And then we have canary deployments, which is like probably the best way of doing things today, where you have sort of like same thing with BlueGreen deployment, where you have two versions running at the same time. It's just that you don't need to have a whole copy. And you are able to start sending users to the new version. And you can start sending like a few percentage at a time and based on different metrics. So you could say typically what companies do is, okay, first, only employees access the new version. So if there's anything wrong with the new version, employees detect it before it reaches to external users. And then you could start saying 10% or 5%, and then 10, and then 15, 20, 30, 40% of users are going to the new version while the other ones are stuck with the old version. And then you keep rolling the percentage of users that are going to the new version, and the other percentage goes to the old version, and you can stop this rollout at any time and start and switch it and send everybody to the old version.
So the main difference, I would say, between rolling updates and canary deployments is that with rolling updates, you're using very simple health checks normally to decide whether to go forward or to go back, without really control who sees what and how. While with canaries, you would basically use heavily rely on metrics to decide whether something is successful, and if it is successful, whether to move it forward another 10%, 20%, or whatever the percentage is. So it is. You can say even that canary deployments is a form of testing where you deploy a new release, you allow certain percentage or certain region or certain users to see it, you test, and by testing I mean evaluate metrics, evaluate query metrics, evaluate the results, and then decide to go forward or backwards. So it is in a way similar to what we would do when deploying to integration environment, staging environment, production, except that this is all happening in production. And the use cases or test cases are based on input from real users rather than imaginary test cases.
And the last way of doing things is, and that you can combine, this is the interesting part about feature flags, that you can combine them with any of the other ones. And feature flags and canary deployments make a pretty good combination. So they are like, feature flags are like toggles, switch that you can turn on and off anytime at your application runtime. That's the interesting part. So you can deliver new features that are off by default to production, and then you can enable them or disable them if there's any issue with it, right? So you build a new nice, like UI, and then you can flip the switch and start showing that new UI to a specific subset of users. And if something is wrong, you just flip the switch again and go to the old version. So it's very nice because you don't even, we were talking about rolling deployments and rolling applications and so on. With feature flags, you don't even have to compile anything again or deploy anything again. It's all happening in production.
You still need to run multiple replicas of your application and do some form of, let's say, maybe rolling updates to prevent downtime, but you do not necessarily need to measure, to actually decide who sees which release, depending on where you're forwarding traffic, but rather by enabling and disabling features in that new release. So it's usually a combination of running multiple replicas in some form of rolling updates, canary deployments, also not combined with the fine-grained ability to enable or disable specific features. While canary deployments are allowing you to enable or disable visibility or specific release, this is rather on a feature level.
Yeah. And I think we heard this before, right? Monitoring is the new testing, in the sense that if you have good monitoring, you can know when users are experiencing issues in production. And not only that, but you could react to the issues automatically. You can rely on metrics to decide whether you want to continue a canary rollout, whether you want to disable a feature flag because it's broken, and you can do very cool things. And like a DevOps board, you used to say to make error is human, to propagate error to all server in an automatic way. That is what DevOps is. And this is the first time we mentioned DevOps in the whole talk, so that this must be a record.
I bet no other talk managed to get this far without mentioning DevOps.
And something I experienced and I learned from that is like, if you haven't automatically destroyed something by mistake, that means that you are not automating enough.
Oh yeah. Actually, if you want to be secure, the best way to do is to do nothing. And then the second best level is not to do anything automatically, and then you get to automation.
So let's go onto an example on how you practically do progressive delivery on Kubernetes, specifically Canary deployments. Let's talk about Istio. If you haven't heard about Istio, it's a service mesh. You probably heard about 5 different of them. Istio is one. And Istio allows us to do very interesting things with your services in Kubernetes. So Istio connects services, allows to secure those connections, doing like automatic encryption, and also control the flow, so deciding what traffic goes to what service, and providing us observability metrics on these services. And the interesting part is that you don't have to do anything to your application. You get all these things for free when you run a service mesh like Istio. Similar with other ones, but this example just uses Istio. And another interesting project, the most interesting project on the sense of Canary deployments, is Flagger. It's an open source project that automates the promotion of Canary deployments using Istio and Prometheus metrics. So when you deploy a new deployment on Kubernetes, Flagger is there listening to events and sees the new deployment if you have enabled Flagger on it, copies that deployment over. So it keeps 2 versions of this deployment, the previous version and the new version. And it uses Istio control to start sending traffic, instead of sending all the traffic to the new version, gradually rolling out to the new version. And you can customize whether you are sending, 5%, 10%, 15%, and whatever number you want to set. This new traffic goes to the new version, and the metrics from Istio are ending in Prometheus. And Flagger looks at those metrics and says, this metric is okay or is not okay. So based on those metrics, it does continue the rollout, or otherwise does a rollback and it starts sending all the traffic to the previous version. So it does this by creating virtual services in Istio, primary and canary services and deployments of your application, and continuously looking at Istio virtual service metrics in Prometheus. And you can even get messages in Slack when these rollouts are happening, because who doesn't need more Slack messages? You also get a Grafana dashboard where you can see side by side old version and new version. So again, all sorts of things like response errors, response times, and you can see both old version and the new version. And it's really cool. It's a really cool project. You should totally check it out.
Yeah. One additional note is that you were hearing about Flagger in combination with Istio. But if that's not your flavor, that's okay, because Flagger supports basically almost any service mesh available. On top of that, it supports, even without service mesh, it can work with Nginx Ingress and a few others. So think of Istio in this context as an example, not necessarily the requirement for Flagger.
Mm-hmm. And now let's go on to the demo.
Yeah! Demo time! Let's take a look at Flagger definition first. It is kind canary. That's not really anything special. What matters is that we are setting provider to Istio in this specific case. We are specifying that the target reference, the application, is running as a deployment, and it is called GoDemo7. Flagger will be monitoring metrics in Prometheus, and depending on the outcome of those metrics, decide to move forward or roll back. We have an application, it's a Kubernetes deployment, we have Flagger, and we have Istio Gateway. Everything else required for that application, like destination rules and virtual services and what's not, all that will be created by Flagger out of the box the moment we deploy the first release. Actually, we already deployed the first release, so we're going to see how the second release comes along, because that's the more interesting part. So let's take a look at the deployments. Now, this is important because here we can see that we have a database. That one is not important, but we have GoDemo 7 and GoDemo 7 primary. Now, GoDemo 7 is the deployment that we deployed. The other one, the primary, is created by Flagger. And that is actually the release that Flagger will consider the production release, while whatever we deploy ourselves will be copied by Flagger and converted into next production release when the time comes, even if all the conditions are fulfilled. Another thing important here that we can see that we have HPA, horizontal pod autoscaler, and here we have services that were already created by Flagger, right? All those here, except the database, were created by Flagger, managed by Flagger. We don't need to do much over there. And the most important one is Canary resource, which there is only one right now, and it is initialized.
I mean, that's the beauty of Flagger, right? You focus on your application, and then it will, from the CRD, the Canary CRD, it will create all these things for you magically.
So what we're going to do next is deploy release 002, and I will show you here the YAML. This is basically exactly the same YAML as of the initial release. The only real difference between this deployment and deployment that is currently running in production is in the tag. On the right side, you will see very soon a loop. Requests will be sent to the application in a loop so that you can see how it progresses, right? The current version of the application, the one running in production, is supposed to output something version 001. And as Canary starts rolling out the new release, you will see increase of the percentage of the outputs that state that the release that is running is 002. Okay, so as you can see, all the outputs are from the existing release, it says version 001. So what we're going to do is apply the new deployment, the deployment of the new release. So the only thing that we are changing in the system ourselves is updated version of Kubernetes deployment. We're not changing anything else. We are not doing any other action except deploying, overwriting the existing deployment with a different image, with a different tag. And we can see that we have two deployments. The new one, GoDemo 7, is currently running 0 replicas. That will soon increase when horizontal pod autoscaler kicks in. And if we look at the virtual services, we can see that we still have only one.
And this makes a lot more sense when you have multiple replicas and even the HPA, the horizontal pod autoscaler, running. So you have more room.
And if you look at the service right now, virtual service from Istio in this case, we can see that there are two destinations, there's the two routes, one sending 100% to the existing production release or primary, and 0% of the traffic is being sent to the Canary release, to the new release. And the reason for those 0% is because Canary Flagger did not kick in yet. Soon you will see the change of that percentage once new deployment is operational and Flagger discovers that there is a change of that deployment.
Yeah, Flagger basically is stopping your new deployment from getting accessed and then slowly turning it on for the users.
And now we can see that the percentage is changed. 80% is going to the production release, while 20% is going to the new release. And if you pay attention to the right-hand side of the terminal, you will see that occasional outputs are now saying version 0.2. Approximately 20% of every 5 requests are responding currently with version 0.2.
And this is random, but you could also set by like HTTP headers and other sort of rules.
Exactly. Currently, rules, if I remember correctly, the definition are based on the error rate, I think, or something like that. Simple one. But yes, definitely in real production usage, you should change that to be real metrics, real queries, real error detection, user satisfaction, or whatever else you deem important to decide whether to move forward or not. So let's describe canaries one more time. And now we can see that canary weight increased to 40%. So it saw that there are no problems, no errors, no issues with the new release, and it decided to move forward another 20%. And if you pay attention on the right-hand side of the terminal, you will see that approximately 40% of the responses are version 0.2, while 60% are version 0.1. And we can see that canaries are now progressing, and 60% of the traffic is currently being redirected to the new release. By default, and this can be changed, once it reaches 60%, it is configured to finalize the release. It assumes that if 60% of your users of the traffic, or whatever the criteria is, has been valid, there is no point probably to continue progressing to 80%. It will jump straight to 100% and finalize the deployment of the new release. So soon, within a few moments, all the traffic, everything coming into this application will be redirected to the new release. That's about it. Now it is promoting, meaning that it is removing the canary release and it is changing the primary release to be the new release. And basically this is it. Even though the process did not finish yet, basically it is finishing our application. All the traffic of our application is now going to the new release. And you can see from the output on the right-hand side of the screen that all the responses are now 0.2. That's it. We're successful. We've proven that it works in production. Just apply it and that's it.
Okay, well, thank you for listening to us today. And we hope you learned that you can do progressive delivery, canary deployments on Kubernetes. It's very easy. You don't have to be Netflix or Facebook or a big corporation to do this. You can just use open source projects to do it. Right, Viktor?
Absolutely. Basically, it's almost too easy. The main difficulty is whether you really understand under which conditions a release is successful. Because you will need to tell, in this case, Flagger, what those conditions are. And that is probably the most complicated part, because it's very easy to say, okay, just move forward 20% every 5 minutes. But figuring out what are the potential errors that the system needs to discover in order to decide whether to move forward or move back is the complicated part. Outside of that, so if you know your system well, if you know under which conditions something is a success or a failure, then it's fairly easy.
Yeah, and it's not only metrics about, HTTP traffic. You could also have your own metrics, like business level metrics, like how many items are people putting on their shopping carts, or how many credit card transactions we have. So you could also, and it will be very nice to have those type of business level metrics that mean more to you.
Exactly.
Well, with all that,
okay, so thank you.
Thank you for being here virtually, and see you next KubeCon.